Before the Docker, actually, we had a servers, physical servers are there. Okay, in that physical servers, I usually deploy the applications. For example, if you go to, I think so, you might be know that virtualization and containerization. Actually, this is the traditional from long back, like in data centers from 4 or 5 years ago, when I was working at the time of starting company. I think so. You might be know some people about this hardware and operating system and application. Actually, usually how it went before going to the virtualization, we had a physical server like our laptop. On top of it, we had an operating system. If you take our laptop is a one hardware, on that we had a Windows, and Windows we had a application, whatever the application. If you are installing maybe Jenkins, that is application like that, just you can able to install the application. Usually from few years back it happened like that, hardware one physical server. On that physical server we have installed the one OS, maybe a CentOS or Windows. On top of it we will run a one application. But later on, after some days, what will happen is we'll get the again one physical server. On top of it, virtual layer means the VMware 5 or 6. That is the one software. Actually, they have installed the one software in on hardware. Just they have installed the one VMware software. On that software, we can able to install the multiple OSs. What is this virtual layer is? It will simply divide the hardware. Means in virtualization also we have a some UI. In that also we can able to create the multiple OSs, multiple VMs we can able to create. In which each VM we should have a one OS. So this is actually previously happened then before the hardware and virtualization. Now again, now the situation we are moving to the containerization. This is the actual. This is the actually virtual machines. In virtualization, each VM you can able to have a one OS, individual OS, maybe a CentOS, Red Hat, or Windows like that. Now again we are moving into the containerization. So containerization means we this containerization is happened based on the container engine. Okay, if you see here again, I will explain. I will explain in Telugu, then it is better to you some people. And ఫస్ట్ ఎలా ఉండేదంటే ఒక హార్డ్వేర్ ఉండేది, ఒక సిస్టమ్, ఒక సర్వర్, ఒక పెద్ద ర్యాక్ లాగా ఉంటుంది, ఒక పెద్ద చాలా పొడవున. అందులో మనం ఒక ఓఎస్, సెంటోఎస్ కానీ విండోస్ కానీ ఏదో ఒక ఓఎస్ ఇన్స్టాల్ చేసిన తర్వాత ఆన్ టాప్ ఆఫ్ అప్లికేషన్స్ వేసేవాళ్ళు. అది జరిగేది యాక్చువల్ ఫ్యూ ఇయర్స్ బ్యాక్. లేటర్ అని ఏం జరిగిందంటే సేమ్ ఫిజికల్ సర్వర్ మీద ఒక వర్చువలైజేషన్ అనేది ఒక సాఫ్ట్వేర్ ఉంటుంది అనమాట. సిడీలో కూడా ఉంటుంది, సిడి డ్రైవ్ లో అట్లా ఉంటుంది అనమాట. అట్లా ఒక వర్చువలైజేషన్ VMware 5, 5.5, 6.1 అలా ఒక VMware వేసాం. దాని తర్వాత ఈ VMware సాఫ్ట్వేర్ ఏం చేస్తుందంటే ఈ హార్డ్వేర్ ని 500 GB ఉందనుకో, మనం ఒక 10 VMs క్రియేట్ చేసుకోవచ్చు ఈ వర్చువలైజేషన్. ఈ 10 VMs కి ఒక్కొక్క VM కి 50 GB హార్డ్ డిస్క్ అలా ఇస్తుంది అనమాట. ఇప్పుడు 500 GBని మనం డివైడ్ చేసుకోవచ్చు 50 VMs కి. ఆ విఎం మీద మనం సెంటోఎస్ కానీ ఏదన్నా వేసుకొని మనం యాప్స్ రన్ చేసుకోవచ్చు అనమాట. అలా 10 OSs రన్ చేసుకోవచ్చు. ఇది వర్చువలైజేషన్ టెక్నాలజీ. అదే ఇక్కడ మనం కూడా చూపించింది. హైపర్వైజర్ వేసిన తర్వాత ఒక్కొక్క VM కి ఒక ఓఎస్ అనమాట. ఇది గెస్ట్ ఓఎస్ అంటే సెంటోఎస్ అవ్వచ్చు, రెడ్ హ్యాట్ అవ్వచ్చు, ఏదైనా దాంట్లో మనం యాప్స్ ఇన్స్టాల్ చేసుకోవచ్చు. దిస్ ఇస్ యాక్చువల్లీ బిఫోర్. Now again we'll get the containerization. So if you want to do a containerization, obviously we require the container engine. Okay, means that means the Docker software. So this Docker software you can able to install in any VM or in your local laptop or any physical machine also you can able to install this Docker engine. Okay, in this Docker engine, you can able to install the multiple apps, like in a app, 10 apps or 20 apps, like that you can able to install. What is this main apps means? This, we are not sharing any particular hard disk or CPU. We won't share to the apps. ఈ apps కేమి మనం పర్టికులర్ గా ఇంత VM ఇంత CPU అని మనం ఎక్కడ ఇచ్చేయం. ఇది ఆటోమేటిక్ గా ఎంత విఎం కావాలి, ఎంత సిపియు కావాలో, ఎంత మెమరీ కావాలో ఈ యాప్స్ అన్ని తీసేసుకుంటాయి అనమాట. ఓకే, ఇక్కడ ఎందుకు ఈ కంటైనరేషన్, వాట్ ఈస్ ద బెనిఫిట్ ఆఫ్ దిస్ కంటైనరేషన్ మీన్స్ we can able to effectively using the environment OS, you can able to effectively use the VM. Okay, that's why you can able to use the containerization. So this will simply we have to install this container engine in, maybe if you can able to install in your local laptop, as I said earlier, you can able to install in physical machine. Means physical machine means here also you can able to install the one container engine. Or usually in each VM you should have a one container engine. In that VM you can able to run the multiple Docker containerization. Okay, this is the basically what is the difference between like virtualization and containerization, this concept. If you have any doubt in this, what is the basic idea you should have as what is the traditional architecture and virtualization, then now we are containerization. Okay, if you have any doubt, then you can ask. Maybe just orally I will tell you. If you understand something, if you have any doubt, then you can ask. Okay, now actually what we will do is we have to create a one VM. Actually now in cloud, whatever the VMs we are created, that is the basically which are there in the hypervisor. In data centers, they are using the hypervisor. Big servers are there, and top of that hypervisors will be there. In that, just you can able to create the they can just simply give the whatever the VMs we required. So in cloud or in AWS, you can create, whenever you are creating the one VM, that is nothing but this VM only. This backend, it will work on based on the hypervisor. Some in data centers, that technology they have used, but that is now we are not bothering about that VMs, VM, all those things. Now I will create a one in VM. On top of it, just I will create Docker. I will install the Docker. I think so. This GCP DevOps 2 previously you have already created. So just I will turn on this one. Means to start this server. Okay, then server already started. Then we will connect this one. Okay, for yourself also to practice the Docker, just you have to create a one server, one VM in your Google Cloud Console. Then this is a simple VM already you have created previously. We didn't install nothing, I think so. Only web server previously we have installed. After that, we didn't install anything. If you want to check this, the what type of version, cat/etc red hat Red Hat -release. Then it will give 7.9. Okay, this is the CentOS Red Hat 7. So in this Red Hat 7, we need to install the our Docker engine. We have to install. Simply this way also you can able to install. Simply you can call this one and you can install like this, or otherwise just you can go to Google and you can simply how to install Docker, in Red Hat 7. Simply you can try this one, install Docker. It is there or not? I think so. If your Docker registry is there, Docker m repo, then it will work. So no, okay, you should root. Install Docker. All of you should have a one Docker registry as well. You have to go to Docker Hub. In Docker Hub, just you can register. Like in a GitHub, you should have created one account in a Docker. I think so. You should have a GitHub account. Similar, like you should create a Docker account in Docker account. Then that is the useful. Here actually in real time, no need to use in the Docker Hub. Some people they have used the Nexus 3 to store the all images. Some projects they are using the GCR, means the Google Cloud Registry. They can use that one. Suppose some people they are using the ECR, means Elastic Container Registry, which are there in their projects. Okay, maybe they are using the AWS environment, they are using ECR. For example, if they are using GCP environment, they are using a GCR. But even they are using a GCP environment, some people they go with a either maybe a Nexus 3 or otherwise JFrog. These all are we can able to store our images, whatever the images we can able to store. But this is a Docker is also they can able to provide the registry, but for that we need to pay private registry. We should need to pay subscription like 100 members or images or repository point of view or a members point of view. You should require some subscription, but we can able to create our own registry, public registry. You can able to create. For that you don't need to pay any money.
So is Docker Hub compatible with all clouds?
Yeah, this is a compatible with all clouds. You can able to If once we create the this Docker Hub, then you can able to push any images from any cloud to Docker Hub. Takes some time. Actually, in this Docker Hub, we should have a Docker. Once if you log into this Docker Hub, then you can able to create our registry. In that, we should be able to store like this. We should have already had, I think so, my account. Non-Mantra 19. And not this one. Docker Hub already I had. I will. Okay, here I had a different images like previously I had pushed some images like 6 months or 1 year ago, some Hanu or MHN Node.js, this Docker. This is the registry name. In this registry, you can able to push the number of images. Okay, these are all images. But whatever the HTTP, some public images will be there. You can able to use that images in Docker Hub. We have some public images like HTTP and Node.js, some public images. You can able to download that one. For example, HTTPD. Here official images. You can get the official images. Whenever you can, once the Docker engine is there, then if you pull the Docker images, that will come from the official website, like an official, or you can able to get from some other your friend's repository also. You can able to get that one. Like Docker pull HTTP. Once if you Docker pull HTTP, then automatically it doesn't ask any username, password. Why? Because that images are the public images. In Kubernetes also backend in each node, they are using one container, one containerization platform, maybe a Docker or some people means most of the images, most of the nodes are inbuilt with a Docker container only. Whenever you are creating any cluster in GKE or anywhere, then automatically they can build that nodes with the help of the Docker backend. If you want, even if you deploy any images into the Kubernetes backend, it will work with a Docker, but we didn't do anything in the Kubernetes regarding a Docker. Just for namesake, you have to know what how the backend will work. Now system CTL status Docker. It will show it is not running. Actually, it is in inactive state. So system CTL status Docker. It is in inactive state. Then you have to start that one. System CTL start Docker. Then you can status. So now Docker is running. If a Docker is running, then how do you know just you can the Docker is working or not? Simply you can Docker images. You will get like this repository and tag, image name, image ID created and size. That means the Docker is already just installed and up and running. There is no problem. Just already it is running. Whenever if you are restarted in a server, automatically at that time, no need to start again Docker. If it automatically, if you want to start that service, then how you can do that one is system CTL enable Docker. So what is this command is? Command purpose is systemctl enable Docker means whenever, for example, if work was completed, then if you stop the server, again tomorrow if you start that server, again it no need to start the again Docker service no need to start. Why? Because whenever the system up and running means in try to boot, then automatically this Docker software also is up and running. System enable. So previously here the enabled is it is the enabled service is like disabled. Now if you check now status, here it is the enabled. Previously in here if you observe, this is a disabled. So the disabled means whenever it is restarting, then automatically that server is not starting. But if you once the systemctl enable Docker, then automatically after start your server, then automatically this service will up and running. Okay. Now this is actually once you are install the Docker, here you can able to pull the any images you wish, like Docker search HTTPD. So if you observe here, the so many repositories available means the Docker this HTTPD is available in so many registries. It is there in this registry in with this name and so many repository, public repository. In public repositories, that image HTTP is there in this repository and here and in this repository, this repository. So many ways you can able to download. But you can simply Docker the full HTTPD. This search means the how many repositories we had that HTTPD. But if you want particularly that one, that is the different issue. Just we should require some login credential and all stuff if it is not public. So public means you can able to pull. So if you are directly Docker pull HTTP, it is official website in whatever the HTTP image is there in the Docker Hub. We have just now we have official image. This official image is already there in the HTTP, the Docker Hub in Docker Hub, public repository in Docker Hub. Then you have simply Docker pull HTTPD. Then you can able to get this image into your local. If you observe here, this image is pulling from the repository.redhat.com HTTPD. Means it is official in official site. We will get this HTTPD. Now we'll Docker images. We will get the one image. So this will come from the registry. Which registry? docker.io/HTTPD. In this registry, this HTTP image will come from this registry. Here, this is the latest image you are getting. In HTTP also we had a versions. If you want like HTTP 2.0, 2.3.1, like that also you can able to get. For example, if you come here, the tags, Docker pull HTTPD latest, the Docker pull HTTP blue C, like the Docker pull HTTP 2.4.51. Whatever the image, if you want, simply if you Docker pull HTTP 2.4.51. If you want this image 2.4.51, you can able to download it. If you're not giving anything, then automatically it will download the latest. So now if you observe here, you will get the latest image. So here everything in the form of layers, we can able to get the image layers. The image is nothing but it is a form of a layers. We can able to build the image on the base image. Means if you want to create an HTTP image, that will create based on the some CentOS image or something like that. So CentOS is a one layer. After top of that, you can create the another layer. Just I will explain in Docker file session how we will build the image. We can able to build image our own also. So not only public repository, but in real time, most of the people they can create the images with help of their own Docker files. So we need to write the Docker files. As a DevOps engineer, we have to write the Docker file for building the image, maybe your Maven or any Spring Boot image like that. Everything is there in the Google. Just but we have to know what are the commands we are using to write the Docker file and to build the Docker image and all stuff. So time being, what we did is simply we are installing the Docker in your server. So just already I have a one server on that. Just I will install the Docker. Simply Docker, how you can install m install Docker. So you are able to install the Docker. Now just you can pull the Docker pull HTTPD. Then we will get it this image. Okay. Next, after that, once the image is there, when you are running that image, it will act as a like a one container, like a server. For example, if you go to the image section, here, after installing the container engine, whenever your image is running, then automatically it acts as a one server, means it will contain all libs and folders. Then you are treated as a one server. Okay. uh, Here you can able to log in the Docker container. It's how you can get the container. Simply the Docker run -d, means if you want to run in a background. So Docker run -d image name, whatever the image, HTTPD. So Docker run -d HTTPD image that are which you have already downloaded this image HTTP. Then you can able to get the one container. So we'll get container already running. How do you know whether container is running or not? Okay, simply the Docker ps command. If you observe here, you can able to see the container. This is the container ID. So whenever you are running an image, you will get the container ID. That image, you will get this container from what image? This image. Based on this image, you will get this container. So it will running in background. Then it is created the 17 seconds ago. And up also, within 1 second, it will up and running. So it is HTTP is basically running in 80 port. So this is the 80 port. Then names. Okay. This is the container name. This is a container ID. Whenever you are running any container, then you will get the container ID as well as a container name. Similar, like whenever you are download the image, or if whenever you are creating the image, that image ID is there, then obviously tag that image. We need to tag to the some repository. Whenever you are creating any image, that need to tag to the some repository. So this repository. Now simply you can just download the Docker pull HTTPD. Then after that you can check the Docker images. Then you will get the Docker images. After that you can simply run the Docker. So you will be able to run this Docker. Now again, if you want to go inside to the container, how you can go inside to the container? How you will log in into the container? So simply the Docker exec -it, then container ID or container name. You can able to give your container ID or container name. There is no problem. Docker exe means execution interactive terminal. So in this the container ID or container name. I have given the container ID. So after that we have to mention for in which cell you have to log in /bin/bin bash. So if you want to log into the any server, we should be log into through some cell. But in server, so many cells are there, like in a bash shell, C shell, so many cells are there. That is the different concept. No need that one. How many cells and all stuff. Just simply with help of this command. But interview point of view, they're asking how to log into the any container. Which command are you using to log into the container? So Docker exec-it, this container ID, then /bin/bash. Then you can able to log into the container. So now we are in a container. So if you observe in container also we have like a Linux files like bin and if you go to the slash, then you can able to see all files like this. Whatever files are there in the Linux server, same files will you should have a same files like a bin, boot, dev, etc. Why? Because this image also will build based on the CentOS or otherwise in any Open SDK or Java Open SDK image, base image, any base image. So obviously, this all software should be required to run a container. So whenever whatever the file systems are there in the Linux machine, Linux lo, CentOS lo, మీకు ఏవైతే ఉంటాయో everything will be there in this also. Just all file systems like a bin, boot, etc. and everything will be there. You can able to move that one also wherever you want. So that's why everything is related to the Linux basic command line. How to what are the files and how you can move from one file to other file. This Linux commands you should perfect. You should perfect. So this is the way you can able to log in into the container. Simply you can exit. Now again you can go Docker PS. So now you can able this is the up and running in the 4 minutes back. Okay, this is the this way you can able to simply download the image and you can able to run the container. Then you can able to log into the container. So how you can stop this container? Simply Docker stop container ID. Then now you can check Docker PS. That container is not running. But if you check with the Docker PS-A, it will show the containers in existing state. What is the difference between a Docker PS and Docker PS minus -A? In interview point of view, also they are asking some cases, what is the difference between the Docker PS and Docker PS-A? What is the difference between Docker PS and Docker PS-A? Is that Docker PS, it will show only running containers. Whether container is in running, then only it will show in the Docker PS. But in Docker PS-A command, it will show in existing state containers also. Now the container, just now we have stopped the container with help of the Docker stop and this one with help of container ID. Docker stop and container ID. Okay. With Docker PS-A. With this command, you can able to see whether even container is also container is not running. Also, you can able to see running means the stopped containers. With help of the Docker PS-A, you can able to see the stopped containers. Okay. Even just you can stop the container, but you are not remove the container. You can able to remove that container as well. So how you can remove that container? Docker rm then container ID. So now you can type the docker ps-a. Now the container is not there. So what I'm trying to say is when we are stop the container, still that container is available. How we can see how you can able to see that one docker ps-a. Okay, docker ps-a command. With help of this command, we can able to see even exit containers also. Means the stopped containers also we can able to see. Okay, then we can remove the container. After that, we are not able to see this one, the docker ps-a. The one second. Okay, then like this you can docker lifecycle is nothing but like you can start how to start the container, how to stop the container, how to remove the container. These are all those things. Again, you can go to the docker images, clear the screen, the docker images. Here the image is there, but you can containers are not there. Docker ps, no containers. Docker ps-a, no containers. So Docker ps means it lists the only containers which are alive, means which are running. The containers which are in running state, if you want to know, then you will go with the Docker ps command. The Docker ps-a command, it will show whether container is running or not. It will show the existing containers as well as running containers. Both containers you can able to see with help of the Docker ps-a. Again, you can run that container, docker run -d, that httpd, the docker ps. It will show the running container. Then docker ps-a, it will show the running container. So the docker ps-a, it will show running container as well as stopped container. But the docker ps, it will show only, it will display only the running container. Now I will create the one more container, the docker-d, same with help of the httpd only. I will create the one more container. Then now we will see the docker ps-a. We will get the two containers. The two containers are there. This is the one container. This is the here. What is the here? With help of the one image, you can able to create the multiple containers. The why actually the docker means previously some persons they will tell like the code is working in my local, but the code is not working in the dev environment, like that they are telling. Then at that time, but generally whenever you are build the image that is working for you, then automatically it is working for others also. Why? Because in your local, if you have a docker in your local in Windows, it is working fine, the docker image in your local. That same docker image you can able to deploy in the any environment. Why? Because there is also we have a docker engine only, so there is a no problem. Here we can able, for example, in your local, if you build the one code and you can build the one image, that you can able to run in anywhere. Either maybe you can run in AWS or GCP and Azure or Oracle or in your local mission. You can able to run in anywhere. Once if you build the any image from from your local and anywhere, can keep somewhere, then you can able to take from the repository, you can able to run in anywhere. That is the main benefit of the docker image. Why you will going forward, why they are using the containerization means, once for example in this docker image, what will be there, our total code will be there. Here in HTTP is also some one applications, web server application. So similar like your total Java code will pack it as an image that you can keep in a either maybe a Docker registry or a Nexus or a JFrog or any GCR or ECR like that you can able to place. From there you can able to take and run in anywhere, either maybe wherever you have a Docker and wherever you have a Kubernetes. That is the benefit. మీరు వన్స్ మీరు ఒక ఇమేజ్ బిల్డ్ చేశారు అంటే ఆ ఇమేజ్ని మీరు ఎక్కడైనా రన్ చేయొచ్చు. అది మీరు ఏ క్లౌడ్లో అయినా రన్ చేయొచ్చు. ఎనీ క్లౌడ్, ఏడబ్ల్యూఎస్, జీసీపీ ఆర్ అజూర్, ఏ క్లౌడ్లో అయినా రన్ చేయొచ్చు. మీరు ఏ కుబర్నెటీస్ ఎక్కడైనా రన్ చేయొచ్చు. ఏ కుబర్నెటీస్లో అయినా రన్ చేయొచ్చు. ఏదైనా మేబీ అజూర్ కుబర్నెటీస్ అవ్వచ్చు, జీసీపీ కుబర్నెటీస్ అవ్వచ్చు, ఎక్కడైనా రన్ చేయొచ్చు. లేదు మీరు ఆన్ ప్రైమ్ కుబర్నెటీస్లో రన్ చేయొచ్చు. మీ లోకల్ మీ ల్యాప్టాప్ లో మినీ క్యూబ్ ఉందనుకోండి, ఆ మినీ క్యూబ్ లో కూడా ఆ ఇమేజ్ ని రన్ చేయొచ్చు. ఎక్కడైనా రన్ చేయొచ్చు ఆ ఇమేజ్. మీరు ఒకసారి ఇమేజ్ ని బిల్డ్ చేస్తే. ఇంకొకటి, ఒక ఇమేజ్ తో ఒక కంటైనరే బిల్డ్ అవ్వదు. ఒక ఇమేజ్ తో 100 కంటైనర్స్ కూడా బిల్డ్ చేసుకోవచ్చు. బట్ అన్ని కంటైనర్స్ మల్టిపుల్ పోర్ట్స్ మీద రన్ చేయాలి. యూ కెన్ ఇఫ్ యూ వాంట్ టు యాక్సెస్. బట్ ఆ ప్రాబ్లం అదంతా మల్టిపుల్ కంటైనర్స్ ఉంటే ఏంటి అదంతా ప్రాబ్లం ఉంది కాబట్టి మనకి రన్ చేయాలి, మల్టిపుల్ కంటైనర్స్ యాక్సెస్ చేసుకోవాలి, ఇదంతా ప్రాబ్లం ఉంది కాబట్టి డాకర్ స్వామ్ కానీ కుబర్నెటీస్ కానీ మనకి యాక్చువల్లీ దోస్ టూ ఆర్ ఇన్ కమ్ టు ఇన్ ఎ పిక్చర్. Why? Because if you want to broadly using the Docker, if you want to scale multiple containers, you can up the containers, down the containers. To avoid these all things for smooth operations, then we'll use the Kubernetes. Previously, before the Kubernetes, most of the people they are using Docker Swarm. Now the Docker Swarm, most of the people they are not using Docker Swarm. Then most of the people use the Kubernetes. So now what I am trying to say is here, you can able to run the multiple containers with help of the single image. Now I will stop the one container. Okay, then Docker PS, only one container is running. One container is there. Docker, again the Docker PS -a, you will see the two containers. What I'm trying to say here is what is the main concept is Docker PS, it will show only running containers. Docker PS -a, it will show the running container as well as a stopped container. That means exit container. Here one is a exit container, another one is a up and running. This container is up and running. So that is the purpose of Docker PS and Docker PS -a. Then already what I said, then how you can remove the container, Docker RM container ID, or you can able to use the image container name also. Now this time I will use the container name. So now the Docker PS -a, that is. So with help of previously I have given the container ID here. Now I will give the container name. Okay, the Docker PS. So next I will start again one container, Docker start. I will run the one container, Docker run -d httpd. Now we will see again the two containers are there up and running. PS -a, two containers. Here, not only the stop command, you can also use the kill command. Also, you can able to use the Docker. Docker kill that container ID. Here, what is the difference between the kill and the stop? The stop, it will take some time, but kill, it will immediately within fraction of seconds, it will kill. This one I'm using this time container name. So within fraction of, both are the similar time, but as compared to the stop, you can easily kill, means within here it takes very less time to stop the container. Now this is an exit state. So this way you can this is the container life cycle, what you are called as how to stop the container, how to start the container, how to kill the container, how to remove the container, this all stuff. Okay, then similar, like you can able to remove the image also. Okay, this all is a container life cycle. Okay, up to now, if you have any doubts, then you can ask.
No doubts at all.
Okay.
Main job is to create the Docker image and run it in the container, right?
Actually, here these whatever I said just up to now, these nowadays actually from the last 1.5 year, they are not some organization still they are using this Docker, some organization, but